Now the cooling only VRF system, this is the most simplest version of the VRF system, and it's really just a more advanced version of a split AC unit or somewhere between a split and a multi-split AC unit. And I say that because the cooling only VRF system can provide cooling to multiple rooms to suit the specific needs of each individual room or zone, but they are much more advanced because each indoor unit only connects to a single branch, being the flow and return, and they also have much better control, enabling them to match the exact cooling load of the entire building. As previously stated, these systems use a variable frequency drive to control the speed of the scroll compressor, and that's allowing the entire system to match the exact cooling load of the building. And this provides huge potential for energy savings and obviously much better thermal control in comparison to a split or multi-split AC unit. Now the cooling only VRF units, these, like I said, they only provide cooling, so they are typically used in warmer climates where there isn't the requirement for heating, or they could be placed within a building in a cooler climate which only has a need to reject heat, such as a computer and server rooms. Now these could also be installed within buildings in colder climates, but you're most likely going to need an additional heat source, such as perimeter radiators or just a combi boiler system. Although this might not be the best approach because you're probably going to get some conflict between the two if the correct controls are not set up. And what you don't want to occur is that the heat being generated by the radiator to heat the room is being absorbed by the ceiling cassette, which is providing cooling. So the two are fighting each other to try and maintain the correct temperature in the room. This would obviously waste a lot of energy, so this might not be the best approach. So looking at a basic schematic of the cooling only VRF system, you can see here we've got the outdoor unit, and indoor we've got all these cassettes, ceiling cassettes. You're not limited to these, you could put them into AHUs, maybe fan coil units, etc. But for simplicity I'm just going to stick with these. And then notice there's a two-pipe system running around here and off to the outdoor unit. Each indoor unit also only has two pipes, and it joins this common feed flow and return, which supplies and takes away the refrigerant. So these are key components of the system, and as you can see it's very simplistic, and it's just a more advanced version of your basic split AC unit, providing air conditioning to multiple zones. So if we have a look on the inside of what's really happening in here, again we've got the outdoor unit here, and then we've got the indoor units. So you can see that all of these are in the cooling mode, so all of them are currently cooling to tell the outdoor unit that they require cooling. So we've got the scroll compressor here, and that's compressing all the refrigerant, and that's pushing this out, and that refrigerant is being pushed off around the system. This is the driving force of the refrigerant around the entire system, and that is heading off over to the heat exchanger, which is acting as a condenser, just like a normal air conditioning unit. So the refrigerant is leaving the compressor as a high pressure, high temperature superheated vapor. And there's a fan in the outdoor unit which is sucking air in and then going across the heat exchanger, and the hot air is then exhausted and rejected out of the top of the unit. And as the air comes across the heat exchanger, then that heat transfer occurs. So this refrigerant inside the condenser here starts to cool down and condense into a liquid. So by the time it leaves the heat exchanger, this will now be a high pressure, medium temperature saturated liquid. And this refrigerant now flows continuously around the building, around this common pipework, and all of these units will feed off of this. Now on each indoor unit, and as I said, these are the cassette versions, so each one employs a electronic expansion valve. This is currently the most advanced version of a thermal expansion valve, and this is what meters the amount of refrigerant flowing into the indoor unit, into the heat exchangers. So the electronic expansion valve is constantly taking readings for this heat exchanger to limit how much refrigerant flows into there to match the exact cooling requirements. On the indoor unit, we've also got a fan inside these, and that pulls air from within the room and pulls it across and blows that across in all directions across this heat exchanger, which contains the refrigerant. The refrigerant is always held within it, it never leaves the system. So the air which is sucked in from the room is blown across these coils, and as that happens, the air becomes cooler, so it sucks in warm air from the room, and then it pushes that across the coil and it comes out cooler, and that is sent around the room to cool it down. So as the refrigerant comes in off this common line and goes through the expansion valve, the refrigerant on the other side is now going to be a low pressure, low temperature vapor liquid mixture. Now as the refrigerant passes through this heat exchanger, or any of these heat exchangers, and it begins to leave the unit, the refrigerant will then leave and join this pipe as a low pressure, low temperature saturated vapor. And the constant force of refrigerant entering into this loop is going to force that refrigerant to continue and circulate back around into the scroll compressor, where it will be regenerated and pushed out again to complete the loop. And there you have it, the most simplest version of the cooling only VRF unit. So that's it for this video. I hope you've enjoyed it. If you have any questions, please leave them in the comments section below, and don't forget to like, subscribe and share this video with anyone you think it might also help. Alright, thanks for watching.